Hi everyone, welcome to my YouTube channel, Intuitive Coding. Today we are looking at this LeetCode problem, dungeon game. So the question is, we have these small rooms, and we start from the first one. The goal is to go either right or down until we get to the last room. And in each room, you will have a point. We have an initialized healthy point at the beginning. So we accumulate the point, either plus some positive number or minus some number. At the end, we'll have a end here. So the goal is we have to make sure when we jump to each room, the accumulated point should be positive. So the question is, what's the smallest initialized healthy point? So how do we solve this problem? This seems to be a classical dynamic programming problem. So for example, if the last point is -5, we have two possibilities. We can go from the top or from the left. So the question we can ask is, what's the least point we have to be when we jump into this room? Because we have to maintain the point to be positive. So we know the least number should be 6. Because when we go to the room, if we have a point of 6, after we do the calculation, we'll have 1. And 1 is the least number we can have. We have to be positive. So that's when we only have one room. Now let's say we have two rooms here. We're from the up to down. We have to make sure, go to this room, we have number 6. That means after we do the calculation of this room, we should have 6. Number of this room is 1. So when we have this room here, least initial number should be what? So the initial number when we come to this room, let's say it's x. So when we leave this room, it's x plus 1. And we know that this x plus 1 is at least 6. So x is 6 minus 1 here is 5. Now we know this initial number of this room should be 5. Let's say we go from the left one. Oh, the number of left one is 30. So the question is, initial point is x. Then we do the calculation, x plus 30 should be at least 6. Then we know x will be greater than minus 24. Can we start with minus 24? No, because to this room, we have to make sure we have a point greater than 1. We have to fulfill both conditions here. So we take the 1 here. We already have this number 6, this number 5 here. Question is, what's the initial number we have to start with when we jump to this room? And the point of this room is minus 10. So we know if we go from left, so we have x minus 10 should be greater or equal to 5. If we go from up, then we know x minus 10 should be equal than 1 or greater than 1. So here we have x should be at least 15 and x should be at least 11. So we will take the smallest one here. So we say x is 11 because after we do the calculation, we can go here. Now, let's generalize this solution. So this is the initial points. We have minus 2, minus 3, 30, minus 5. So this is the initial dungeon data. And we will use dynamic programming. So we have a table called DP. First, so the number should be 6 here. How do we get 6? 6 is equal to 1 minus 5. That's this number minus 5 here. Because we know at least we need to have the number 1 at the end after the calculation. Now we come to this room. The question is, what's the least number we have to have so we can make sure when we jump from this room to this room, we will have at least 6. So like I said, we should have at least 1. And 1 minus 30 will have 31 here. It's greater than 6. So that's good. What about this room here on the left? After we add this 10 here to this number, it needs to be at least 1. So again, this room should be 1. 1 minus 10 will be 11, and that is greater than 1. How about this room here? Well, after we do the calculation plus 1, it has to be at least 6. So we know this room should be at least 5 when we come to this room. So 5 is actually 6 minus 1. For this room here, we have two pathways. We either right or go down. If we go right, and because we have 2 minus 10 here, so this number x minus 10 should be at least right, which is 5. Go down, minus 10 should be greater down, which is 1. So we can write out our code here. The input is the dungeon. So first, we can get the number of the rows and the columns will be the length of the list itself and the length of the first row of the list. If the number of the rows is 0, that means the list is empty. We just return 1. And then we need to initialize DP. We can define it later. Because we are doing it in the reversed order from here, right to left, and bottom to up. For I in the range of 2, 0, when we go in the reverse order. And then for j in the range n to 0 in the reverse order. So the question here is, what's the value of the dpij? Either this number is from the number down or the number on the right. So let's define from right and from down. Then we can know this number should be the minimum of from right and from down. This number, let's say is x here, plus tangent should be greater or equal to the number on the right. So we know x greater than right minus tangent. And here x should be greater than down minus tangent. Remember that we have to make sure x greater than 1 and x greater than 1 here. So we can write this in another form. X should be x of 1 and right minus tangent. The max of 1 and down minus tangent. And we can replace the number x with, let's call it from right and from down. So we plug in the from right and from down. The number of dp here should be the mean of from right and from down. Note that we don't need to have the whole matrix. Every time we can just use one list and then go from right to left. Then we go to next row and then the last row here. At the end, we'll have number here, which is dp0. That's the number we need to return. So instead of a whole matrix, we can just define dp as a list. We need to initialize the list. Here we initialize as float infinity for I in range and the number of the columns. And because we need to calculate the last row and last column, so we use n plus 1 instead. A little bit tricky here. We need to initialize dp n minus 1 to be 1. So instead of dpij, every time we are asking what's the number of dpj, minus 1. So we can revise this part, dp j minus 1. The from right should be the max of 1 and right minus dungeon. So what's the right? Right is number on the right, so that number is dpj. Minus dungeon. Dungeon here is actually dungeon I minus 1, j minus 1. Just because we start with m, not m minus 1, 2, 0, actually it's m minus 1, m minus 2, until 1. So that's just an issue of the notation. And we can rewrite the from down into max 1 down minus dungeon. So minus dungeon is the same thing. And the number down is actually the same number before we update the dp. So it's dp j minus 1. That's the current number of this dp here before we update it. So after we loop through I the row and j the column, at the end we will have the whole dp. So we just return the number of the first value in the dp. That is the number here again. So this is the whole procedure of this dynamic programming. Let's see the code. It's exactly the same thing I just showed you. Just instead of IAJ, I use row and column here to be more informative. If this is helpful to you, please consider subscribe my channel